So we have started with a two simple examples. So this one was very easy. We can see that this 3x and this 5x were clearly we can add these two terms. So 3x plus 5x gives me 8x and this 5y minus y gives me 4y. So this would be my final answer. Now solve the next one. So now this was the next example. So we were told to exactly simplify this expression. So now we can see that we have to just collect these like terms first of all. So in this case, in the first term, we can see this 3a square over here. So if I just collect these a square terms together, so this is 3a square minus a square. So just have a look at this term and this plus 2a square over here. And just for your understanding, just keep this thing in mind that you have collected all the a squares in the entire expression. So after just gaining this understanding, then at some point of time, you will be able to just solve it orally as well. It is actually so simple that you wouldn't be required to even write everything just like this. That visualization would come in your mind very fast. So now comes these AB terms. So it is a 5AB over here. 5AB and over here it is minus which becomes plus, so it is plus AB and this plus 3AB over here. So we have collected all the ABs together. Next comes these B square terms. So there is a 4B square in the first term. Next is minus 2B square. So it would be 4B square minus 2B square and plus minus becomes minus B square. This is the expression. So this is 3a square minus 2a square, which is a square plus 2a square. 2a square plus 2a square, which gives me 4a square. And over here there are 5ab plus ab, 6ab plus 3ab. So total 9 ab's are there. So plus 9ab. And next is 4b square minus 2b square minus b square. So this is 4b square minus 2b square. This gives me 2b square and another minus b square. So only b square we are left with. This is my final simplified version of the given expression. Again a very straightforward question, but we need to just practice this and get a hold over this, because ultimately we are going to use this basic understanding for so many times. So now let's solve one more. So now this was the term. So exactly in the same manner as we have solved the last question. In this case, first of all, we were able to see that there was only one variable involved now. So that was only x. The only variable is x. But the terms were not like. Some terms were involving x square, some were having x, and there were constants otherwise. So let's first collect the x square terms. So it would be a minus x square over here, plus 3x square from this term, and minus x square from here. Now if I just collect the x terms, so it would be a 3x from the first one, then a 5x, and then minus 7x. Now the constant part, plus 2 from the first term, minus 8 from the second one, plus and minus becomes minus 8, and minus becomes plus 7. So this is the expression. So the first term gives me 3x square minus x square minus x square. So 3x square minus 2x square, which leaves me just an x square over here. Next is 3x plus 5x, 8x minus 7x is x, and 2 plus 7 is 9, 9 minus 8 is 1. This is my simplified version of the given expression. So just keep this thing in mind that when we write a polynomial completely, we start with the highest degree term, and then ultimately we just write the terms in decreasing order of degree, in the decreasing order of powers. So in this case, this term could have been written in this manner as well. But this wasn't the right way of writing it. This wasn't the most correct way, because whenever you will actually see a polynomial from now onwards in any book or anywhere across, it would always be written in a descending order of the variable terms, the variable powers. So in this case, you can see that the highest power term was x square. It is written as the first term. Then it was x, which is x to the power 1. And the constant term is actually a term with variable to the power 0. We can write this 1 as 1 multiplied by x to the power 0. So this is a term this is the coefficient of a term where variable is having a power of 0. So this is the way of writing it as well. So this is again very important. So now let's understand that next logic, which is again very straightforward. So in today's class only we are going to dive into the next understanding, that is multiplication of these polynomials. So let's first understand that. So now comes the task of multiplication of these polynomials, which is again actually very straightforward, but you need to just understand the basics first. So what happens is this. So let's say a square is multiplying with, let's say 2a square is a term. 2a square is a simple monomial. This is multiplying with, let's say 3a cube. This is to be multiplied with 3a cube. We know that this 2a square cannot be added to this 3a cube because we can see that a square is a different term and 3a cube is a different term. So this a square and a cube are not like terms. They cannot be added. But if I just multiply these two terms, so what does this means actually? If this 2a square is to be multiplied with this 3a cube, so can we now see that if I just write this a square, we actually know that ultimately a square means what? A square means that a is being multiplied 2 times and then a 3 is being multiplied, and this a cube means that a is being multiplied 3 times. So if I multiply this entire expression, we can see that this ultimately means that 5 a's are being multiplied. So this a square when multiplied with this a cube term, we can see that we can simply combine these two expressions and just add the powers. So this 2 and 3 can multiply amongst themselves. So this gives us 6, and we know that a to the power m when multiplies with a to the power n, it gives me the value as a to the power of m plus n. So we have used this sense over here. So a square multiplying with a cube directly gives me a to the power of 2 plus 3, that is a to the power 5. This is the basic strategy. So when these two monomials are multiplying, we can see that the final result would be 6 times a to the power 5. So